Hello and welcome back to Biology. I am Mr. Kubuske, and this is Cathedral High School in Indianapolis. Just wanted to touch base again. I know it's been a while since we've had a chance to kind of chit-chat, but to be honest, some of the things we've put together in the past have worked out pretty well for our classes here at Cathedral and for our teachers. But one thing that we're constantly looking at new ways to present and new ways to talk about is evolution. And after a couple years of working with it and talk about it with both students and teachers, we've come up with an interesting way to kind of introduce the idea of how things have changed over time, basically by connecting all the different parts of what we know as the story of evolution and really the story of everything. So that's kind of where we're going to begin today. Now, some of the things, if you're in my class, there's some videos and things like that that I've shown you as a part of this presentation that I can't necessarily show you on here because they belong to other people. But if you need to see that, please feel free to contact me and I can give you the links to the videos that I'm kind of talking about. But without further ado, let's get started talking about where everything kind of began and the Big Bang Theory. So the Bare Naked Lady song from the TV show, the Big Bang.
Our whole universe was in a hot dance.
Right. Well, believe it or not, there's a lot more to that song than what you hear on TV, and it's actually a pretty good song and gives you a lot of information that's actually kind of accurate as to the history of our universe, starting with the Big Bang. So the Big Bang is a widely accepted theory as to the origin of the universe. We actually have a lot of mathematical precepts and facts that back up the idea of the Big Bang, but we still call it a theory because it's not like you can go back 13.8 billion years ago and actually watch it take place. But we've actually been able to use our really high-powered telescopes and, like I said, some mathematical formulas to show that the Big Bang Theory is actually what probably occurred. Now, a lot of people think of it as a giant explosion. It really wasn't an explosion necessarily. Like, things weren't destroyed. Actually, it was quite the opposite. Things were created. In fact, within the first couple minutes of the Big Bang, every element on our periodic table was created. But before that didn't necessarily exist. It was all kind of combined. All matter and everything in the universe was combined in an area no bigger than the size of an atom before this Big Bang took place. So really it's like an expansion. It's the universe expanding kind of into itself, because you got to imagine that you have the universe and then outside of that is nothingness. So really it's not necessarily expanding anywhere other than into nothingness. So the universe, all that there really is. So, but the idea that the universe expanded, it's constantly getting bigger, and that in this quick expansion, things started to happen where energy and matter and dark matter and antimatter, whatever you want to call it, are kind of all created at that time within the first couple minutes or first couple 100,000 years of the life of the universe. But as I mentioned, the universe is about 13.8 billion years old. It created all elements on the periodic table. It causes the universe to expand. There are some believe that it's going to expand to a certain point and then it'll actually contract again, and then we'll go through another Big Bang once it contracts in on itself. There's some that think that maybe the Big Bang, this is like just the most recent iteration of it, that maybe it's occurred multiple times and it's just the universe's way of kind of resetting things. It's kind of interesting to think about and have conversations about. But for our purposes, we should know that the Big Bang Theory occurred about 13.8 billion years ago. It's considered a theory because we can't go back and watch it, but we have a lot of evidence that proves that this is actually probably what took place. So the universe is still expanding. We can see the galaxies are actually still moving, and it's still moving at a pretty steady rate compared to where they are in relationship to the distance from the origins of the universe, or where the Big Bang actually took place, which our scientists actually can kind of, at this point, pretty much pinpoint. But the other thing you should understand from this is, like, as that expansion is occurring, things were sent hurtling, in different directions, at millions or thousands of miles an hour, including the gases that were created. And so we've got these large gas clouds that, as they fly through our universe, collect more and more gas as they pass by. And the bigger they get, they start to create gravity, because, or it's not necessarily creating it, but they start to have gravity because their size continues to grow. So you've got these giant gas clouds kind of hurtling through space, and as they become so big, they begin to condense upon themselves. And I'm going to borrow a video here to kind of expand upon that a little bit more.
Over the next 10 million years, the molecular cloud slowly contracts under the force of its own gravity.
As our gas cloud collapses under the force of gravity, to become a star, something very interesting happens. And I'm going to try and demonstrate what happens with these two lead balls in this carousel. Now, I'll step up here on top of the carousel. I've now increased my mass by the mass of two lead balls, and I'm holding them straight out. So now the mass in my body is distributed at a distance far from the center.
Fleming is impersonating a molecular cloud. The weights represent its mass, which to start with is spread over a huge area.
Now, I'm going to ask Lucy to give me a hand here and give me a little bit of angular momentum. As I start spinning, I'm going to move the balls closer to the center of my mass, and notice how faster I'm spinning. And when I bring them out, I slow down again. And as you can see, this is exactly what happens to the interstellar cloud.
The large molecular cloud had a small rotation. When it shrank, this rotation speeded up. As the cloud contracted, the energy of the material flying in from space caused its center to heat up. This spinning ball became our sun. The rest of the cloud was spinning so fast that it spread out into a vast disk of dust and gas. This was the cradle of life, the material that would form the Earth and all the other planets.
There you go. And so that last part there, it might be the most important part moving forward, but it's important for you to understand that. So we have this giant gas cloud, and as it's further out, it spins slowly, but as it gets smaller because of gravity, because of its condensing on itself, because it's gotten so big, then when it gets smaller, that spin goes faster, a lot like a figure skater, like you see the one down here at the bottom. So that generated heat, that spinning, and so the center of it heated up so much it became our star, our sun, in the center of our solar system. But all that other stuff was left around, that dust and debris, that interstellar dust and debris, kind of in circles around the sun, and those are going to give us the basis, the building blocks basically for planets, and we'll talk about that here. But the formation of our solar system occurred about 5 billion years ago, so make sure you know that number as well. So at the same time the sun is forming, that rock and debris in that gas cloud starts to form around the sun, as we mentioned, and the pieces were moving so fast in so many different directions, sometimes they would collide into each other. Well, they would hit so hard, they wouldn't just bounce and ricochet off like curling stones. Instead, really what would happen is they would hit and they would fuse together. They would become almost like a plasma of molten rock and fuse together to become a bigger piece of debris. And then that would happen again and again, and this would happen constantly, daily, hourly even, in the life of these little things. And they would get a little bigger and a little bigger and a little bigger. And eventually, there were so many of these collisions that the rocks started to disappear and became just one giant rock that we now would know as a planet. And so that's kind of how our planets were formed. So each of these pieces of dust added to the future planet's size. And as it grew, it got stronger gravity. So in other words, it's pulling more things to it. And so there would be even more and more strikes. And so in our original solar system, when it was all kind of said and done, we had about 20 planets in that original solar system. So you may ask yourself the obvious question, well, right now we have 8, and then some planetary bodies like Pluto and Xena and so on and so forth. So what happened to the rest of them? Well, that's a great question. So about 4.6 billion years ago, we say the Earth is formed. Technically, the Earth and the building blocks of it are older than that, but it got its final shape and size about 4.6 billion years ago. And what happened is that the Earth actually collided with another planet called Theia, and when that happened, most of Theia became a part of the Earth, but some of Theia, which scattered about because of the violent collision that took place, kind of formed a ring around our planet. Well, again, because those rocks and that debris was moving, they were constantly bouncing into one another, that basically became the formation of our moon. And so what evidence do we have this took place? Well, the Earth is unique because it has 2 cores. There's a solid core and then a liquid core. That's kind of unusual for a planet. So those 2 cores probably came from these 2 different planets, the original Earth and then Theia. Earth has a strange tilt on its axis of 23 degrees. It should have been straight up and down. Well, that tells us that something happened to kind of knock us off that axis, and that has to do with this collision that you see here. And then the final thing is the moon. And we can see the scars, those craters on the moon's surface that kind of give us an idea that this is probably what took place. So the moon was actually created from this violent collision that gave the Earth its final size and gave us that tilt on our axis. So now we've got our Earth, we've got our moon. The Earth is like super hot right now, molten rock, and that's basically all it is at this time. As those rocks were melting, gases were being released. If you think about it, if you melted a rock, it's not just going to become magma. There's some that's going to be released into the atmosphere, and so that started to happen. And the Earth was finally big enough that it could hold an atmosphere. And so we had an atmosphere full of methane, ammonia, hydrogen gas, all poisonous to you and I, and water vapor. Well, as that Earth began to cool over hundreds of thousands of years, that atmosphere cooled as well. And if you know anything about an atmosphere, when it cools, the stuff that's in it starts to fall as rain, which is exactly what happens on Earth now. Well, that rain helped to cool the Earth even faster. And so now we start to have a rocky surface to our planet, and then we also have this atmosphere filled with water, gaseous water that fell to the Earth as liquid water as rain. Well, it'd be a little different than right now. Right now when it rains, most of our water percolates into the soil, but we didn't have soil. It was just rock, and so it just sat on that surface. And so we actually had a surface full of water. We had an ocean that covered the entire planet. Well, at the same time, the planet is still super hot, so that water wasn't just like lukewarm or the temperature of our oceans now. It was like boiling. And so this constant heating and cooling of this water caused for some really weird weather patterns. Well, really, our first weather patterns ever. And violent storms raged across the planet. Now, you may think that that's insignificant, and you say, well, why would I give you that information? Well, each of these things is necessary to start life on this planet, which we're going to talk about the next time we get together. So we began with the Big Bang Theory and the formation of our solar system. We talked about how the Earth was formed from that gas cloud, and the moon was formed from the collision of two planets. And now we've got our Earth that was a ball of magma, now has a rocky surface full of this boiling ocean with this violent storm raging around it. Well, again, we have all the pieces basically that we need now to do life on this planet and create life on this planet, which is where we'll pick up next time. I appreciate you coming back and visiting us. If you need more information, please visit mrkubuske.com or contact us at jkubuske@gowithhero.com, or you can follow me on Twitter at Coach Kubuske.